In this video, we will see how to bake a procedural material to color, metallic, roughness, and bump maps. In the previous video, we learned how to create a procedural material in order by creating a clay pot material. So, in this video, we will learn how to bake a procedural material by baking the clay pot material we made earlier. If you want to watch the video of making this clay pot material, there is a link below in the video description. First of all, here, let's see what are the benefits of baking a procedural material into maps like this. A procedural material is a complex flow of such material nodes. So, the GPU and CPU devices of the computer have to work hard to render such complex node flows like this. Here, we can bake this color, roughness, metallic, and bump maps that are generated through this procedural node flow to separate images. And then, by connecting the baked images to the principled shader again, and we can convert this complex node flow into a simple flow of a few material nodes. So, this node flow can be rendered through our GPU and CPU devices easily. Another advantage of baking procedural materials is that when an object with a procedural material created using the Blender is used through another 3D platform, these baked texture maps can be used to recreate the material of that object. Okay, now let's see how to bake these maps. There are a few basic things we need to consider when baking a procedural material. First of all, to bake a procedural material, there must be an object that uses that procedural material, and there must be a UV map for that object. Secondly, the image connections must be linked to the procedural material to obtain separate outputs of color, roughness, metallic, and bump maps. After these things, we can bake these texture maps for images using the UV map of the object. Okay, now let's get started to bake our maps. Let us first start by generating the UV map here. So here, set the viewport on one side and the UV editor on the other side, according to this layout here. After that, select the object and switch to the edit mode. Here you can see that the UV map for this object has already been created in this project. Let's see how to generate a UV map of an object like this from scratch. If you know how to create a UV map of an object, you can skip this section and go to the next section. First, select the object you want to create a UV map and switch to the edit mode. You can see now that there is no UV map for this pot here. To generate the UV map, as we want for this object, we must first seam mark this object. So, let us now see what this seam mark is. I will now select this object completely in the edit mode and try UV unwrap here. Here's how this object unwraps the UV map before seam marking. Now, for example, I will seam mark two small parts on the surface of this object and unwrap the UV again. After UV unwrap, you can see how the two seam marked parts are now unwrapped separately here. Thus, it is now clear to you that by seam marking we can cut this object the way we want and unwrap the UV of it. Okay, now let's seam mark and UV unwrap this object the way we want. First, I will clear all the seams here. Now here completely separate the bottom foot of this object. So, select this face and seam mark this. After that, switch to edge selection, then select a line with vertical edges on the inside surface, as shown here. You can use the hotkeys used here for this. Here is how the selected verts should look through the wireframe shading. Okay, now seam mark this. Now you can select this completely and UV unwrap. In addition to this unwrapping method, Blender has a smart UV unwrap option. For complex objects, it is difficult to seam mark and unwrap. So, you use smart UV unwrap to unwrap such complex objects. Also, you can use this smart UV unwrapping for this object if you want. But here I use the seam marked and unwrapped UV map for this. Okay, let's bake texture maps now. I will start baking from the color map here. So, let us now set the node preview for the output of the procedural color map here. This node preview is set using the Node Wrangler add-on. You can enable this add-on in the add-on section of Blender Preferences. Now set the node preview for the output of the procedural color map here. Then, add an image texture node and create a new image for it. Now let's set the name, width, and height values here. Rename this as a color map and select width and height together. These values set the size of the image that is now being created. For this, you can use this same value here, or twice this value, or a value that you need. The details of the baked map will increase depending on the image size you use here. For this clay pot, it is suitable to give for height and width values of 2048. But I give 4096 image size value to bake this part with more details here. You can also use this value as well. After setting all, now click the OK button here and create the image for this map. Now let's bake the map for this image. First, go to the Bake section of Render Properties and select the Emit option for the baking type here. Now you can bake this color map by clicking the Bake button here. Before that, here are a few things you should always consider to bake the texture correctly. We are going to bake all these maps here based on this node preview. So, it is important to set this node preview for the procedural node output of the map you want to bake. Second thing is, the image texture node that is set for the map to bake must be selected in the shader editor. Third, you need to set the sample size to bake these maps. This sample size uses the render sample of this scene. And the details of the baked texture map also depend on the number of samples you provide here. So, samples of 64 or higher values are required to bake texture maps. For this, I give a value of 64 here. And then, press the Bake button and bake the color map. This will take some time. Okay, now we have baked the color map here. You can see the baked texture by setting the node preview to the image texture here. In this way, we can bake the rest of the maps. But there is a difference in baking the bump map. The roughness and metallic maps hold the same method. So, we will first bake these maps and then see the bump map part. Now, as before, set the node preview for the roughness output of the procedural material. Then add an image texture for this and create a new image. Rename this as a roughness map and create this with the same size as this image. Now, bake this map. Then set the node preview for the metallic map as before and set a new image texture node for this. Now, rename this as a metallic map and create this with the same size as this image. Then, bake this map now. Okay, now let's bake the bump map here. Let us first go to the bump texture out of the procedural material. Here, we will not set the node preview for this bump node. The reason is, this bump node gives the normal map output. But, what we need to bake the bump map is the connection that is connected to the height value of this bump node. This is the real bump map output of a procedural material. So, set the node preview for this and add an image texture node to this as before. And then set a new image called bump map. For this, we will use the same height and width values as we used for the other textures. But we can't use bump maps by baking into normal bit size images. For this, we need to use an image with a larger bit rate. Here, we can check this 32-bit float option and set this image to the number of bit range we want to bake the bump map. So, now check this 32-bit float option and then press the OK button. Now let's bake this map. This is the bump map now we baked. And this is the same bump map without enabling the 32-bit float option. You can see the difference. This one without enabling the 32-bit float option is messed up here. That is why we use 32-bit float images to bake this kind of map. Okay, now we have baked all the color, roughness, metallic and bump maps in this procedural material. You can save these baked texture maps through EEVEE editor. Here are the texture maps we baked. Here you can save all the required textures in your computer directory through the Save As option. Since I use these textures only in this Blender project, I will use this Save All Images option instead of that Save option. Using this option, you can save baked images textures inside the current project. After saving the texture maps here, now move all the image texture nodes in one place in the material. And add a new principled shader here. Let us now connect these relevant textures one by one. Before that, arrange the image textures nodes in the order of color, metallic, roughness, and bump respectively. Doing this will be easier for us to connect them. Now let us set the node preview to the principled shader. And now connect the color map to the base color value of the principled shader, and the metallic and roughness map to the metallic and roughness values of this shader, and the bump map to the normal value here. Then finally add a bump node to the bump map connection here. After adding that, swap the bump map image texture to the height connection of this bump node. The values of this bump node should be the same value as the procedural materials bump node. Here, both of these values are 0.5 for this clay pot procedural material. Here is how this material works with the EEVEE engine. And here is how this material works with the Cycles engine. Here, when I connect this material node connection to each of these procedural and baked materials, you can see that the Cycles render preview sampling speed is higher for baked material of this. So, let us render this clay pot using these two material types separately and compare them to see which one is faster. So, first, set node preview for the procedural output here and set render settings for this scene. These render settings are similar to the render settings we set for rendering this procedural material in the previous video. If you followed this session from the previous video, you can skip this section and move on to the next section. Now adjust the sample size here to 500. Here, by using adaptive sampling you can avoid taking render samples unnecessarily through the render process. For this, we do not use any render denoising here to get the correct details of the materials. And the tile size here should be in line with the rendering device we are using here. I will use both GPU and CPU devices to render this. So, I have to give the tile size that fits the CPU rendering. If you are only using a GPU for rendering, your GPU tile size should be 128, 256, or 512. You can enable the GPU setting for the Cycles rendering through Blender Preference. If both your GPU and CPU support Cycles rendering, CUDA device selection will show both your device as options. By enabling those two options you can render using both GPU and CPU devices. After setting that, now you can select GPU compute for render device here and get started rendering this scene. I will use both GPU and CPU devices to render here. So, I have to give the tile size that fits the CPU rendering. Okay, now let's render this. This is the final output of our procedural clay pot material. It took 2 minutes and 51 seconds to render 500 samples of this material. Here it is common for procedural materials to render so slowly. This is because the GPU and CPU have to work so hard to generate and render all the details in this material. Now let's render this pot using the baked material out of this. So, first, here in the render result window, select slot 2 to get the result of the baked material. After selecting that, now close this window and connect the material out to the baked texture map connected principled shader. And then render this now. Here, we use the same render settings for both renderings, so we can see how fast the baked material output is. This is the final output of our baked procedural clay pot material. It took 51 seconds to render 500 samples of this material out. So, you can see that this is faster than using procedural material directly. According to the render results of this project, the render time of this baked procedural material is 3 times faster than the render time of the direct procedural material. Furthermore, the details of these baked materials show no difference to the details of the direct procedural material to the naked eye. Now you can use your material for other softwares by using the Blender and baking it for the object you want. And also, these baked materials can be easily used for the EEVEE engine of the Blender. The question that many 3D designers and game developers have is, what is the connection between this normal map and the bump map? And, is it possible to convert this bump map to a normal map? So, we will see how to convert the bump map of this procedural material to a normal map and then bake that into an image texture map. And then, we will see more things about these two maps in our next video. Also, if you have not yet seen how to create the procedural clay material we used here to bake maps, you can watch the video through the link in the video description below. I hope you have learned something new from this video. If you liked this video, hit the like button. If you want to watch more videos like this, subscribe to our channel, click on the bell icon on the side, and select all. This will allow you to receive notifications for future uploads. If this video helps your Blender work in any way, don't forget to comment on how. If you have any other issues with this video, please comment as well. And if you would like to support us, please share this video with the Blender users you know. Learn with IBN.